Okay, so let's start with an example. Okay, so then we will use this chart here to understand the how do we use the chart. Okay, so example says that we have a research study on employee performance based on the office environment. Okay, so we have three different departments and each have different lighting. So the department A is dim, one's B, and one is C, and we check for a performance. And these are the performance of the employees. So the question says that, so first we will have to put forth our hypothesis. Okay, so we have the null hypothesis and we have the alternate. Null hypothesis, as we said before, and then here as well, so there's no change in performance based on lighting. Okay, and then B will say that which is opposite of the null hypothesis, at least one group of employees, okay, performance differently, okay, depending on lighting level. So this one should be lighting level. So this is the how we start the experiment. Okay, these are our hypotheses before we start the experiment. So the next one comes, how do we test it? So next is that we have to test the hypothesis. Okay, to test the hypothesis we have different roadmaps. The first one is that we have to first check for the number of groups. How many groups do we have? If I go back here, we have 1, 2, 3 groups. Okay, so we have 3 groups, which means that we have to go this way. And then how many factors do we have? If I go back, we have one factor only, which is the lighting. So we have one factor, which is lighting. But this factor has 3 levels, which is dim, bright, and natural. Okay, so we have one factor but 3 levels, so we go this way. Can we assume normal distribution and equal variance? For our class, always yes. And we will use one-way ANOVA. That's how it works. But if the number of groups were 2, then we can go this way. Again, always we will have the normal distribution and equal variance. And then comes that is it paired test or not. So paired test means that, so we check the same population before and then after the test. This is what is called as a paired test. Unpaired means that we compare 2 different groups. Okay, so like you check, for example, treatment on the person A. Okay, so you check it for before and then after. This is the paired. You dependent, so you have the same population for the test. So saying that, so I will just go to ANOVA one way in Excel, and then we will try to solve this problem. So let's do that. Okay, so this is the Excel chart that we have the department performance levels. Okay, so what we do is that we go to data, analysis, and we look for ANOVA single factor. Okay, so we have ANOVA 2 factor, but here we have single factor, which is the lighting. But lighting you have 3 levels, okay, so that doesn't mean that we have 3 factors, just one factor with 3 levels. So I'll just go with the first one, and then I just choose my variables here. and then I don't have any labels in the first selected input data, but it asks, are my data in groups or in rows? But as you can see, they are in rows. I will just go this way. Output range, let's go this way and click here. Okay. Do you see that? So the only thing that you have to check for this one is that this part is just the statistics. It gives you the count, sum, the average, and the variance. You see variance values are similar, but we have to check for the p-value, okay, which is very, very small. Okay, so you can see that p-value is 1.5 10 to the power of negative 23. What it means? So it means that so you check for p-value. Okay, so if p is less than 0.05, okay, so we reject the null hypothesis. If p is greater than 0.05, so we accept the null hypothesis. In this case, the p-value is less than 0.05, so we reject the null hypothesis, so we reject it, and we accept this one, that one group performs differently, at least one. So we don't know whether it is the department A or department B or department C. But we know one is different, but which one we don't know, okay? So the next would be that we can check which group performs differently, okay? So that will be another part. Okay, so for now, this is how it works. So, but what it means, that what this value means, this value of 1.5 10 to the power of negative 3 means that, so 1.5 times 10 to the power of negative 3 means that, so the probability of this data to happen, this data or similar extreme ones, to happen is, so 1.5 times 10 to the negative 21%, because this one is negative 23 times 100, 21%. So under my null hypothesis, okay, so under my null hypothesis, the probability that this one, the data here, see, so happen is that 1.5 10 to the negative 1, 21%, which is very, very low. It cannot happen, but it happened. It cannot happen with my null hypothesis, but it happened. So that means that there is problem with my null hypothesis. Okay, that problem is that lets me to reject it. But as I said, the single factor ANOVA doesn't give us which group is different. It just tells us one group is different, but we don't know which one. To find the which group is different, so we may need to do a t-test. What it means is that we just choose two groups and check for it. So let's do that in the next recording.